Well, let's find a power series for f when f is cosine of x. This lesson is amazing the way it blends together series with derivatives and integrals. It ties everything together. It's beautiful. All right, let's do it. I know that f is cosine of x because they said so, so I just felt like writing it again apparently. And I'm going to write down what that power series is, which is from 0 to infinity, of negative 1 to the n, and then x to the 2n over 2n factorial, because cosine is an even function. That's why our exponents are even. Well, that exponent is even. And that gives me, well, you plug in a 0, you get a 1. Plug in a 1, you get x squared over 2. Plug in a 2, you get x to the 4th over 4 factorial, almost said the wrong thing, and then minus x to the 6 over 6 factorial, which is 720, that's good to know. And then you can just keep on going with this thing, and you're going to have the general term, which of course you've already written, negative 1 to the n, and then x to the 2n over 2n factorial, and you keep on going. Now, if you want to use the factorial instead, feel free. It's actually going to be quite convenient if you do. I just didn't for some reason. Okay, let's move on to number 2. Find f prime. Stop right there. F prime, that's negative sign. You've seen this before. But now we're going to see it represented in a different way, and you're going to see how that same answer pops up in a different way here. So, f prime would be, all right, the derivative of cosine, which would be negative sine x, which is, and I'm going to skip this guy right here. I'm going to jump to these, which is what they really asked for. This was me just like cranking out an idea. Hey, I remember it, but this is going to guide me in my next answer, which is the first 3 non-zero terms in the general term. Okay, we're taking a derivative. You've done it before. The derivative of 1 is 0. The derivative of negative 1/2 x squared would be negative 1x. The derivative of x to the 4th over 24 would really be, scrap paper, this would be, treat it like what it is. That's really 1 over 4 factorial x to the 4th, which means we would multiply 1 over 4 factorial by 4. That gives me 4 over 4 factorial x to the 3rd, which really means I have 4 over 4 times 3 times 2 times 1, which gives me 1 over 3 factorial x to the 3rd, okay? Just saying. It's a neat little process. So this is plus x cubed over 3 factorial. You can guess what the next one is. If we took the derivative of this guy right here, 720, by the way, not the most obvious of all factorials, it's 6 factorial. We would have negative 1 over 6 factorial, x to the 6, taking the derivative of this term. So we'd have negative 6 over 6 factorial, x to the 5th. That's negative 6 over 6 times 5, 4, 3, 2, 1. And those cancel, and I'm left with negative 1 over 5 factorial, x to the 5th. That's what that is, okay? These little doodlings I've done here, it's going to come in handy when we get to the general term. You watch, it's going to be great. So x to the 5th, 5 factorial, and then we have our general term. We're going to take the derivative of that as well, and when we do, we'll have, well, something right here. We don't know what that something is, so let's just start experimenting with the derivative of this. And I'm going to write it like a polynomial. I have some doodling on this paper. Actually, it's bleeding through. Let's get a blank piece. Let's do a little doodling. If you want to just scribble this in a margin, you can. I just wanted to put it on a separate piece of paper. We have negative 1 to the n over 2n factorial. I just like to write my coefficient as just a pure coefficient, and then x to the 2n, right? I'm going to take the derivative of that, the way I've been doing derivatives for a long, long time. Negative 1 to the n over 2n factorial multiplied by 2n. That puts the 2n in the numerator. You can see what's about to happen. And then we'll subtract 1 from that exponent. And then we can simplify this coefficient. So negative 1 to the n, and then 2n over 2n, and then 2n minus 1, 2n minus 2, 2n minus 3. You can see where this is going, and I think you do see it. So it's negative 1 to the n over 2n minus 1 factorial, whoops, and then x to the 2n minus 1. That is the derivative of the general term. You're just taking a derivative. You've done it before. It just looks a little different now. So negative 1 to the n, x to the 2n minus 1 over 2n minus 1 factorial. I rewrote it just a little bit differently. This is what I had here. This is what I had here. But it's the same thing. Now, the power series for sine is positive x, negative x cubed over 3 factorial, plus x to the 5th. So it would be positive, negative, positive. Well, now, because it's negative sign, it's the opposite. Now, if you're also noticing this 2n minus 1 and the 2n minus 1, it's just still giving me an odd exponent, an odd denominator that we're going to factorial. All right, now we're going to take an integral, and things get a little bit different here. We're going to let k be the integral from 0 to x of f prime of t dt. So check this out. We're taking the integral of a derivative. These are inverse operations. The integral of a derivative is going to take me back to my original function. So when I'm done, I better have cosine. Or am I? Let's see. It's going to be interesting. Watch this. Let's take the integral from 0 to x of f prime of t dt, and we want the first 3 terms in the general term, and this was the first 3 terms in the general term. So why don't we integrate f prime, which was negative sign, which is this. So we're going to just put this in this integral. Now, I have done this problem before and out of habit made the mistake of, oh, it's x and x. Actually, no, it's t. So let's do it accurately. So negative t plus t cubed over 3 factorial minus t to the 5th over 5 factorial plus dot, dot, dot. Let's keep going. Negative 1 to the n doesn't change. Whoops, not 2 and not x, it's t. T to the 2n minus 1 over 2n minus 1 factorial plus dot, 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 forever and ever and ever, dt. Okay, we're going to integrate this, and we're just going to integrate one term at a time, and I've got what I need here. The first 3 terms and the general term. So the antiderivative of negative t would be, well, negative t squared over 2, right? Parenthesize, because you'll need it. All right, antiderivative of this guy would be, let's see, t to the 4th for sure. And what I would have is, check this out. Here's our old trick. This is what I am taking the antiderivative of. So I would take the antiderivative of that. We're going to add 1 to the exponent and then do old coefficient. Let's doodle on the side here. Old coefficient divided by new exponent, which really gives me 1 over 3 factorial times 1 over 4. Well, this is 4 times 3 times 2 times 1. That's really this. That's what I get, and plus c in this context, but we're having a definite integral here. All right, so this is t to the 4th over 4 factorial, and it is positive. You can see where this is going. This is not x. Apparently I couldn't see where it was going. This is t to the 6 over 6 factorial. You called it 6 factorial. That's technically 2 factorial if you want to get technical about it. Do you need to see this one? Do you want to? Do you? No. But if you did, here's what it would look like briefly. Old coefficient divided by my new exponent, 6, 5, 4, 3, 2, 1. That's where that comes from. All right, let's proceed with the general term. And when I do, I'm going to add 1 to my exponent. I'm going to kind of break this one down and do it in a slightly different way. So t and then 2n minus 1 plus 1 is t to the 2n. Now I'm going to figure out what my coefficient would be. And, whoops, not dt there. I'm getting ahead of myself. Getting way ahead of myself. There's some more that's going to happen here. We haven't figured out the coefficient yet, and it's the same idea. You can probably see where this is going, but it's my coefficient, 2n minus 1, old coefficient, divided by my new exponent, which is 2n, so times 1 over 2n. And then I have 2n times 2n minus 1, 2n minus 2, 2n minus, oh, well, this is just 2n factorial. There we go. That's what it is, negative 1 to the n over 2n factorial. And if you want to write it like the fraction that it was, watch this, up here you can, I just didn't. And this is going to happen from 0 to x. So here's what we do. We plug in an x for all my t's, and we'll figure it out in air quotes. X to the 4th. That's the sound of an equal mark. Plus that. Negative 1. Let's go ahead and make that an exponent. Or make it in the numerator, I mean, put it in the numerator. And then 2n factorial plus that. And then I would subtract away what happens when I plug in 0. Well, you plug in a 0, you get 0 and 0 and 0 and 0, so it goes away. So this should be cosine, right? We just took the integral of the derivative of cosine. The derivative of cosine is negative sine. So if we're taking the derivative of an integral, it takes us back to cosine. So this is cosine, right? Is this cosine? Close, but in the process we lost our constant right there. Neat, huh? Hate it when that happens.